The sound started like a single, sustained, high-pitched hum, the synthetic fiber of the forward breastline singing under unexpected load. The tanker MT Kestrel was a steel island tied up at the Galveston Offshore Terminal. It was July 14, 1978 at 10:55 in the morning. She was over 800 feet of dead weight and she was light in the water. Ballast tanks nearly full, but the freeboard still high, catching the wind like a sail. The port side was secured to Pier 4. We were waiting to start the final heavy sequence of crude oil loading. The delay was caused by a pea soup fog. It had rolled in thick after midnight. Visibility was maybe 200 feet. Port Authority required a harbor tug tied to the offshore quarter before the heavy loading pumps could turn on. The tug, the Sea Dog, was stuck in the channel waiting for the visibility minimum to lift. Third Mate Jenkins was supervising the after mooring station. He was signing a log sheet when the first shift happened. The whole ship, that entire 800 feet of mass, settled and shifted maybe 6 inches away from the pier. Jenkins looked over the side. The gap between the hull and the heavy rubber fenders had opened. It was a slow, deliberate movement, like a man leaning into a stiff breeze. "Mr. Jenkins, the breastline is tight," reported Seaman Riley from the capstan controls. "The breastlines run perpendicular to the pier, holding the ship in. They should have been slack enough to breathe." Jenkins picked up the radio handset. "Bridge, this is aft mooring. We have a sudden load increase on all lines. I estimate a 7-inch set-off from the pier. The stern line is running heavy." The bridge responded instantly. "Understood. After his chief mate is already assessing the situation. Forward. Stand by." The wind had shifted. It had been calm offshore, but now it was blowing steady from the north-northeast, directly onto the Kestrel's starboard side. It wasn't a gale, maybe 7 or 8 knots, but 800 feet of high steel hull presented a huge surface area. That wind was now a steady, constant push. The ship was no longer floating passively. It was being driven sideways against its moorings. Chief Mate Miller was already moving from the cargo control room toward the forward mooring deck when the call came. He didn't run. Running suggests panic. He walked with long, measured steps, focusing on the problem. He checked his watch. 10:57. The situation was starting now. On the forward deck, able seaman Henderson was standing next to the number 1 capstan. The capstan is the rotating drum used for hauling in or paying out heavy lines. He was watching the forward headlines. These lines ran out parallel to the pier, holding the ship from moving backward. "Check the lead, Henderson," Miller said, coming up to the rail. "It's tight, Chief. Very tight. They're taking all the tension," Henderson replied. "And look at the shear line." The shear line, or forward spring line, ran from the bow back toward the center of the pier. It was supposed to stop forward movement. That line was taut, stretched to its limit. The ship was not just moving out, it was moving forward along the pier. It was dragging itself along its own lines. The total drift along the pier was already estimated at 4 feet. This might not sound like much on a vessel this size, but the key issue was the loading arms. The arms were articulated steel pipes resting just forward of the ship's midpoint. They had a physical limit for how far they could be stretched, both sideways and along the pier. That limit was only 10 feet. If the ship moved 5 more feet forward, the arms would start to bind. If it moved 10 feet, they would fracture the manifold or the arms themselves. That would be a major disaster, resulting in an oil spill and heavy steel damage. Miller took the radio. "Jenkins, report aft drift." "Aft is moving back, Chief. We've drifted roughly 6 feet back from the original chalk line on the deck. The stern line is strained." The wind was pivoting the ship slightly around the center point, creating enormous opposing forces at the bow and the stern. The bow was driving forward. The stern was driving back. The lines were being stretched like rubber bands. Miller looked at the loading arms. They looked solid, still well within tolerance, but the margin was closing fast. He looked at the Port Authority representative, who was standing a few feet away, pale but silent. Miller ignored him. This was a ship problem now. "Henderson, get a set of binoculars. I want an eye on those loading arms. Call out if they look strained or if the flanges start to open up at all." The plan was clear. Stop the longitudinal forward-backward movement and pull the ship back to the pier. Do both without snapping a line. Miller needed hard numbers. He couldn't trust just his eyes. On a large ship, when you see a line under strain, it's often too late. He went to the electronic tension monitor installed near the forward capstan. The readings confirmed the danger. The number 1 forward headline was showing a calculated load of 92,000 pounds. The braking strength of that 12-inch synthetic line was 120,000 pounds. They were operating at 76% of the safe working load. Too high. That line was under extreme stress. The remaining lines were also strained, but the headlines were the worst. "Jenkins, what's your aft stern line reading?" Miller radioed. "Aft load is 85,000 pounds, Chief," Jenkins reported back. "Same line size. We're holding, but the line is showing friction burn at the chafing gear." Chafing gear is protective material used to prevent lines from rubbing against sharp edges. The immediate risk was not the wind. It was the physics of the mooring lines. Synthetic ropes stretch dramatically under load. When a line breaks, it doesn't just snap, it recoils with deadly force, capable of severing limbs. Miller had seen it happen once in his 20 years at sea. He was not going to let it happen on his watch. "We have maybe 8 minutes before the load on that headline passes 95,000 pounds, Miller calculated aloud to himself, checking the rate of load increase. The wind was steady, but the line was yielding slowly. "It will break within 12 minutes. He had to take weight off the headlines and the stern lines. The solution was the spring lines and the breast lines. The breast lines needed to pull the ship back to the pier. The spring lines, running forward from the stern and backward from the bow, needed to stop the dragging motion. "Bridge, inform the engine room," Miller called. "I need a low-pressure discharge of water on the port side midship. Just enough pressure to help hold us against the pier." This was a trick, using the ship's own fire pumps to create a very small counter-thrust. The bridge confirmed, "Engine room advised. They are ready to engage the number 1 pump on your command, Chief." "Stand by," Miller replied. He needed to coordinate the line work first. Water pressure might help, but the lines were the primary control. Miller walked to the number 2 breastline capstan. This line was running out at 90 degrees to the pier. It was the best line to pull the ship back in. "Riley, on the aft breastline," Miller commanded over the radio, "I need you to take up slack. Not fast and not full tension. I want that line at 50,000 pounds and then hold it there." 50,000 pounds, Chief." "Copy," Riley confirmed. The sound of the capstan motor, a high-pitched whine, started aft. It was a slow, deliberate winding. Jenkins watched Riley operate the controls, ensuring the line was taken in smoothly. The line tightened, pulling the heavy stern section slightly back to the pier. Forward, Miller turned to Peterson, a junior seaman. "Peterson, you are on the number 1 headline capstan. I need you to ease that line. 5 turns. Slow as you can. Pay it out. Now." Peterson moved the lever. The capstan groaned and the line began to move out. This relieved the pressure, allowing the line to stretch further without snapping. The load on the monitor dropped from 92,000 to 88,000 pounds. This bought them a critical 2 minutes. "That's it. Hold it there, Peterson. Don't move that lever." The ship now had slightly more space from the pier, but the main breast lines were holding the distance, and the danger of the lines breaking was temporarily reduced. Next, Miller focused on the forward drift. The bow was still trying to slide forward. He needed a stronger brake. "Henderson, get a new spring line rigged," Miller ordered, "forward to aft. Use the spare 10-inch fiber. Rig it to the second set of bow bits." The spring lines were the true brake. They ran diagonally along the length of the ship to a far bollard, a sturdy post on the pier. Henderson grabbed the new line. "We don't have time to walk the messenger, Chief. I'll use the launch gun." "Go," Miller said. The line launch gun was a brass air pistol that fired a light line called a heaving line across the gap. It was quicker than throwing it by hand. The blast of the gun was sharp in the fog. The small weighted projectile shot across the 7-foot gap and landed perfectly on the pier. A longshoreman waiting on the pier, having seen the initial drift, immediately grabbed the heaving line and pulled the heavy new 10-inch spring line across. Time taken for rigging and securing the new line, 4 minutes. At 11:15, the situation was stabilized but still critical. They had more lines out, but the wind was relentless. The headline was creeping back up to 90,000 pounds. Miller made the call for the critical maneuver. This was the moment of highest risk, using maximum force on the lines and simultaneously engaging the water jet. "Bridge, engage the fire pump. Low-pressure discharge, port side, midship, now." "Pump engaged, Chief." A dull thrumming sound came from the engine room, and a brief churning of water near the waterline confirmed the counterthrust. It was minimal, but every pound of force helped. Miller then focused on the new third spring line Henderson had just rigged. "Henderson, you are on the new spring line capstan. I want you to take up the load slowly. I want that line to feel the strain. Bring it to 75,000 pounds and hold it." 75K, Chief. Copy that." The capstan motor whined again, louder this time. The new spring line, which ran far back down the pier, started to tighten. This line was designed to resist forward motion. As the line tightened, the entire 800 feet of the Kestrel began to decelerate its slow slide along the pier. The most dangerous part was the coordination. If the new spring line was tightened too fast, it would transfer the entire pulling force to its own bollard on the pier, potentially shearing the fitting. If it was tightened too slowly, the headline would break first. Miller watched the tension meter jump from 90,000 to 95,000 on the original headline. "Peterson, pay out the headline. Pay out 3 more turns now," Miller yelled over the wind. Peterson, pale and focused, engaged the winch drum. The headline released tension. The load dropped back to 85,000 pounds. Meanwhile, the new spring line climbed to 73,000 pounds. Henderson held the lever steady. The ship's forward movement stopped. The deck was still. The steel sighed in relief. "Hold all lines steady," Miller commanded over the radio, his voice calm but strained. "We are holding position. Repeat, we are holding position." The next 15 minutes were spent in this state of high tension. The crew stood at their capstans, hands on the controls, watching the lines, adjusting the winch brakes in minute increments. The fog was still thick. The wind was still pushing. Miller noticed a small wisp of smoke coming from the new spring line's sheave, the pulley through which the line runs, where it was rubbing against the steel fairlead. The line was generating heat due to the immense friction and stretch. "Keep a water spray on that fair lead, Henderson. Small nozzle, just a mist. Don't soak the line, just cool the steel." A hose was quickly brought out. The light mist of water hissed as it hit the hot steel. The smoke stopped. The crew had stabilized the ship at the maximum permissible risk limit. They were now in a prolonged holding pattern. At 11:45, the waiting paid off. The constant low rumble of a heavy marine engine could be heard through the fog. It sounded closer than expected. "Bridge, this is forward mooring. That's the Sea Dog. She's close." The voice of the master, Captain Olson, came over the radio. "Affirmative, Chief." The fog lifted just enough in the channel for them to proceed. "They have visual on the port channel buoy." 5 minutes later, a heavy, blocky silhouette emerged from the gray vapor near the ship's stern quarter. It was the tug MT Sea Dog. She was slow, powerful, and handled with immense precision by her captain. Jenkins on the stern spoke into the radio. "Tug is approaching the quarter. Stand by to receive a line." The tug maneuvered to the offshore starboard side of the Kestrel's stern. The tug's deckhand threw a heavy heaving line across the gap. The Kestrel's crew secured the heavier hawser, the towing line, that followed. It was a massive 14-inch synthetic tow line, far stronger than the ship's mooring lines. "Tug has a line on the quarter, Captain," Jenkins reported to the bridge. The tug captain, a man named Davis, spoke directly to Captain Olson over the VHF radio, which was patched to the deck speaker. "Kestrel, this is Sea Dog. I'm going to hold you to the pier now. I will apply slow, steady force on the quarter." "Understood, Captain Davis. Proceed slowly. We have heavy strain on all forward lines." The sound of the tug's engine changed. The low rumble became a steady, deep roar. The twin propellers bit into the water. The tug began to push gently against the 800 feet of the Kestrel's hull, counteracting the wind. The effect was instantaneous and visible. The high-tension hum of the lines dropped in pitch. The tension meter on the number 1 headline plummeted from 85,000 pounds to 60,000 pounds, then down to 45,000 pounds. "Ease all lines slowly," Miller commanded, relaxing his grip on the radio. "Ease them all in concert, starting with the tightest ones. Hold the tug's pressure." The capstans whined in reverse, paying out line as the tug pushed the ship back toward the pier. The gap closed from 9 inches back to the original 3 inches. The lines went slack. The crisis was over. The tug's presence was the overwhelming external force needed to nullify the wind's push. At 12:05, the ship was secured. The tug settled into an idling hover, maintaining gentle pressure on the quarter. Loading could commence. The first priority was to restore the mooring arrangement. The emergency spring line was no longer needed. "Henderson, strike the shoreline," Miller ordered. "Coil it and check for chafing. Look at the lead of the headline when it ran over the bullnose. The bullnose is the heavy steel fitting at the bow, where the line passes through." Henderson and Peterson began to unwind the emergency spring line. It was hot to the touch. Where the line had run through the fair lead for 25 minutes under extreme pressure, the fibers were melted and fused into a rough, glossy surface. It was permanently weakened. "New spring line is scored, Chief. Heavy abrasion and fusion damage," Henderson reported, holding up a section of the rope. "Jettison it," Miller stated. "Mark it for immediate replacement. It held, but it's done its job. We'll use a fresh spare." The breast lines were checked. The number 2 breast line, which had been under the most initial load, showed significant internal damage, evidenced by a slight change in the line's diameter and stiffness. It was also pulled and stored for inspection. Jenkins reported from the stern, "Chief, the aft stern line held, but the rubber fender it was resting on is torn. Minor damage to the fender. Rubber only. No hull contact." Miller went to the manifold area. He checked the loading arms. They were still perfectly aligned. The slow, controlled easing of the headlines had prevented the arms from being pulled beyond their safety threshold. If the line had snapped, the shock load might have warped the arms instantly. The crew tidied up. Coils were reorganized. The capstans were cleaned. The entire incident, from the first hum of the line to the final securing by the tug, had lasted 1 hour and 10 minutes. No major equipment was lost. No one was injured. Miller checked the log and wrote the final entry for the incident. It was factual. 12:15 mooring arrangement restored. Tug empty Sea Dog secured on starboard quarter. All lines stable. Strain breast and spring lines segregated for replacement. Commence loading sequence. The Port Authority reviewed the Kestrel's log entries and the condition of the jettisoned lines the next day. The official finding was concise. The log showed that the load on the number 1 headline peaked at $95,600 text pound dollars at 11:15, only 4,400 pounds below the breaking point. Investigators confirmed that the wind, steady at 8 knots from the north-northeast, had created a cumulative lateral force of approximately 100,000 pounds against the vessel's high freeboard. The report noted that the timely and controlled paying out of the most strained headline, combined with the immediate deployment of an emergency spring line, prevented a catastrophic failure. The chief mate's decision to utilize the engine room's fire pump for low-pressure side thrust was cited as a non-standard but effective measure. To assist the initial line adjustments, providing an estimated counterforce of 5,000 pounds, which was enough to break the friction point. The official summary concluded, "The crew of the MT Kestrel demonstrated exceptional adherence to safe procedural seamanship under escalating stress. The line failure was averted by early detection and methodical load distribution. The integrity of the cargo transfer manifold was maintained at all times. There was no citation issued, only a formal commendation for operational control. That day on the Kestrel was not spectacular. There were no flashing lights or helicopters. It was just an hour of quiet, intense work in a thick gray fog, managing a slow, heavy problem. The interest was in the routine, in the knowledge of the job. It was about knowing exactly when the line would snap and making sure it never got there. The ability to manage a ship comes down to small, precise decisions under pressure. That day showed that the true danger on a ship is not often the storm that everyone can see, but the relentless, steady pressure from a 7-knot wind that shifts at the wrong time. It comes down to coordination, knowing the limits of the equipment, and the training to execute a move without wasting a single second or word. They didn't save the ship from sinking. They saved the routine from being broken by a $100,000 line failure and a major environmental incident. That is the job.